Data visualization through 3D printing is an innovative trend reshaping how we interact with and interpret digital information. This approach finds applications across various fields, including art, science, and education. A striking example from the art world is the visualization of Neil Armstrong's iconic quote, "One small step." In science, topographical data naturally lend themselves to 3D representation. However, 3D printing technology is versatile and suitable for visualizing any data represented as a surface in Cartesian space. In education, tangible models created through 3D printing not only spark curiosity among students but also enable visually impaired students to engage directly with data, breaking barriers to understanding. For example, in chemistry education, data from modern techniques such as two-dimensional nuclear magnetic resonance spectroscopy and chromatography have been successfully visualized using 3D printing, as reported in academic literature. This video demonstrates the visualization of data obtained using gas chromatography, mass spectrometry, abbreviated as GCMS, and showcases how an R script can transform these data into a 3D, printable STL file. GCMS data should first be exported to a CSV file. Many software tools bundled with GCMS instruments have this functionality built in. Exporting to a CSV file typically requires just a few mouse clicks as demonstrated here using software from Leco. Alternatively, GCMS data can be exported to a binary netCDF format, and then processed in the R environment, although this workflow is outside the scope of this video. The R script reads the CSV file where GCMS data are presented in tabular form. Users can adjust several parameters to generate a model of a specific physical size. These tunable parameters include the width of the mass spectral peaks and the gaps between them, the full width at half maximum of a chromatographic peak, the height of the tallest peak on the fragment. The following table serves as a guideline during this setup, summarizing the results of test prints conducted during the optimization phase. A 3D, printable STL file is generated using the R2STL-R package. Due to some limitations of this package, users must currently set the dimensions of the final model manually in their preferred slicer software. The required dimensions are displayed in the R console. The GCMS data were printed using white PETG filament and used as tangible materials in mass spectrometry classes. These models provide a unique way for students to interact with complex datasets physically, generate genuine interest, and facilitate better comprehension of the material. The description of this video includes links to the corresponding STL files, and provides all the necessary information to 3D print your own GCMS data. Thank you for watching.